In this video, we are going to answer the question of how to play this model. So first of all, we need to download NetLogo software. We can click here, go to the official sites to download it from here. After it, we can check the original paper and the original model from this site. And if you want to play the updated model, which I provide the model right here. To use the model, after you download it, just double click and you will run. Okay, so that will be easy. Now, let's look at the model, see how we can play it. To play it, we well, first of all, need to understand all these parameters right here. There are parameters about the macroeconomy, which include inflation, interest rates, and parameters about the owner of the houses and the realtors for the houses, and of course the house themselves, and other parameters. Also, while we play in the model, we will examine these charts. These charts will give us a lot of information. And to play the model itself is very easy. Basically, first of all, we need to set up everything. We need to set up the world, set up the model. And we need those parameters to be set for the baseline. Therefore, we will choose the baseline right here and then click Setup. And then click Go. The model will run itself. Now we can examine these charts. Okay, so that's how we play the model. Because we know that the model is trying to tell us how the markets would behave under different circumstances. So we can try different scenarios. For example, the normal condition is 7% interest rates. That is abnormal, okay? But in this paper, there is a baseline which sets the interest rate to be 7%. So we consider this as the baseline. So from the baseline, if the interest rate drop to 3%, we will see what would happen, okay? So first of all, we use baseline to set it up, and then we ask the model, once it's running in the middle parts of the, once it's running to the 200 ticks, we will drop interest rates to 3, because the whole model will run for 400 ticks. So 200 ticks is like halfway through, okay? So let's go. So let's watch it. It's nearly 200. Once it happens 200, see, that's a abnormal movement, okay? Here, from 200, suddenly the price shooting up. So obviously when the rates drop, the price actually rised, okay? So we can try different scenarios to see what would the market price react towards these different scenarios, different cases. Okay? But to understand what is going on, we have to understand the parameters themselves and also what exactly does this plot trying to tell us. So first of all, let's look at all those baselines. What does those baseline parameters want us to know? So to do that, we need to go to Setup, and we will explain these parameters. It's kind of very easy. We set inflation to be 0, meaning inflation is actually 0%. Interest rate 7, meaning interest rate is 7% per year. Ticks per year is 4 ticks equals to 1 year. So 400 ticks is 100 years. Cycle strength 0, meaning there's no variation introduced to interest rate. Affordability 25, meaning 25% of the income can be used to pay for mortgage. Saving 50%, so 50% of the income will be saved. X rate 2, meaning 2% of owners will exit the city due to death or relocation of the jobs. 5% of interest of entry rates, meaning 5% of owners are newcomers entering the city each tick. Mean income 30,000, meaning the mean income of the whole population is 30,000. And this will be used to calculate each person's income using a gamma distribution. Shock 20, meaning 20% of the whole population will get an income shock, okay, either going up or going down. Maximum homeless period 5, meaning the maximum duration of homeless that anyone can endure before they exit the city. So basically, all those parameters has been explained using the comments, so you can read this yourself. And for the plots, may need a little bit explanation as well. Here we have the title of different plots. Here the title is income averages, and right here we can find income averages. Okay, so this is the plot we are talking about in the code. So in this plot, there are two lines. One line is to plot all the owners' income, all the owners their mean income. Okay, another line is to plot all the owners for their income to take the median. Okay, so we have two lines. One for the owner's income mean, the other is the median income. Another plot named count houses owners, and we will count how many houses in the city. So one plot is counts the houses, another plot is counts the households. The third line is to count the number of households who already have a house to live in. Okay, and there's another plot named people in and a house demolished. There are three lines to be plotted. One line is to count at each tick how many people exits the city, how many people. Another line plots how many people entering the city, and the third line plots how many houses has been demolished. And just like that, we have all these plots name and the lines being plotted, and the comment is explaining what's this line trying to tell us. So by reading all these comments and the title, you will have a basic idea what each plot's trying to tell us. Okay. So after knowing what each parameter is trying to tell us and what each plot is trying to tell us, now we can further doing experiments with these different scenarios. And if you want to know more about scenarios, you can go to Go function and examine these scenarios. So LTV is when the model come in the middle way, comes to the 200 ticks, the maximum loan value will drop from 100 to 60. If we choose scenario interest rates rise 10, then when it comes to 200 ticks, the interest rates will rise from 7% to 10%. If we choose poor entrance, then when it comes to 200 ticks, the mean income will drop from 30,000 to 24,000. So these are different scenarios we will play around. Okay, so once you know what each parameters mean, what each plot mean, you can have some idea how the housing markets would react to different scenarios. Okay. Finally, this model is complex. The code, there's an enormous amount of code here, and there are multi-agents involved. How do we know this model works as we expected? Well, we have to verify it with the well-observed complex phenomenon. And according to the paper, and also according to many textbooks talking about how do we verify ABM, this type of modeling, uh, one way to verify it is to see whether the well-observed complex patterns can be replicated, can be generated by the model. And if they do, if our model can generate those patterns, then our model is verified. So you can try those different scenarios. And as a matter of fact, in the paper, it's described certain patterns. And, I have tried the model, and our model can generate those patterns. So you can check these 4 videos. There are different patterns has been described in the paper, and we can actually generate those patterns as expected. So, to some extent, this model is verified, I think, and you can try out yourself. And finally, if you want to know how we can update the model from the original one to the current one, you can watch the earlier parts of the videos. This is a kind of history record how I update the model step by step to the current stage.